Hi, I'm going to present my project to build a prediction for the electrical energy output of a combined cycle power plant. It uses a combination of gas turbines, steam turbines, heat recovery. So as you can see, we have the data like temperature, ambient pressure, relative humidity, exhaust vacuum, and net energy. Net hourly electrical output is what we are trying to predict here. Okay. So the approach which I have used is supervised learning, as we have all the labels which are properly labeled. Okay, and we have a good set of past observation which are well known. So regression model seems quite appropriate in this case, and I believe it is a good model to start with. So I've taken two model approaches in regression. One where I'm using three features: temperature, exhaust vacuum, ambient pressure, and second one where I use all the four input features, including the relative humidity as well. Okay, and this is the formula which came up to. I have done using an Excel file, as you can see here. So this is a model one where the R square value came this. These are the coefficient values. And this is a model two. Okay. For the training data, I have included around some 7,600 records, which is approximately 80% of the available observations. And test results will be like 20% of that data. So it comes to around basically 1970 records. So as you can see here, and in the test data, I have two columns I've added. One is the prediction for model one, and second is the prediction for model two. Okay, the model one formula, as you can see here, and the model two formula as well, and both are added here. So as I mentioned, the validation set is approximately 80% of the data, which is the training data, and the remaining other test set data. Okay, in this case, what I have observed is model two shows a better performance. How? So let's see how we have come to that conclusion. So what I have used for the output metric is the R square score value. It explains well how the variance is from the target, and more the R square is near the one is considered to be a better model, right? So in my model one, the R square value came out to be this, and model two, the R square value is 0.92, which is slightly higher than model one. And from the test result, which I am going to show you, you can see that the model two gives much better prediction compared to model one. So if you come here and notice, I'll just take few examples, even in the first case, right? The model one is around 436.7, but if you see the model two prediction, it is much more near the actual prediction value, which is 434. Okay, so let's take any other example also here. Row number 7, the model one prediction is 471 approx, and model two prediction is 473, which is much near to the actual energy output. So considering all these factors, I've come to the conclusion my model 2 is better performing, and that is the one I'm going to select for this particular application. So as I mentioned, the linear regression model 2 performs well here, and it makes a good baseline also. It is a highly interpretable, especially in the scenarios where the explainability is critical, right? So if I'm forecasting some energy here and I cannot explain why it is giving me a better interpretation, better prediction, then it will not make sense to my actual users, right? So this is all about my project, and thank you for watching it. Thank you. Bye bye.